I welcome all of you on the platform of YourPedia Education. And as you know, Team YourPedia has recently covered the first ever research and development fair, which was held in IIT Delhi. We participated there on 15th of October 2022, but it was for 2 days, 14th and 15th of October. In this particular R&D fair, some 23 IITs participated, and very good research projects were displayed there for the benefit of students, teachers, entrepreneurs, and all. Now we have started one particular series where we are interacting with the professors, with the scholars who are behind these particular projects, who have done marvelous work in their field of research, and we are interacting with them. Today, my guest here is Professor Tripathi, Professor Sachchida Tripathi, who is from IIT Kanpur. And Professor Tripathi has done marvelous work in the domain of air quality. So his project, IoT-based sensor for industrial emissions and air quality monitoring, was one of the main attraction in that particular fair. He has done marvelous work in the field of protection of Taj Mahal from discoloration, to prevent the Taj Mahal marble getting colored from air pollution or something. He has done marvelous work in the field of narrowband IoTs, and to make the technology indigenous. He has worked in the field of laser scattering sensors. He has worked in the field of low cost sensors that eventually leads to the indigenization of the technology, and Make in India initiative. Let me share with you the project which was displayed during this fair, and the project which was conceived by Professor Tripathi. So as you can see, this IoT-based sensor for industrial emission and air quality monitoring, this is the project which was displayed in IIT recently in the trade fair, in that particular fair. And you can find out a lot of things related to air quality, the new technologies. He has worked a lot in the field of monitoring and measurement of particular 2.5, which we call particulate matter 2.5. Very good work is done in that field, and also narrow band Internet of Things. So I'm sure that you will get a lot of benefit if you go through this entire interaction of 1 hour with Professor Tripathi. Those of you who are looking forward to have very good research career in this particular field, please listen to this in totality, and I'm very sure you will get a lot of advantage and benefit through this particular interaction. So let's see, and let's interact with Professor Tripathi. Good morning, Professor Tripathi, and thanks a lot for your time.
Thank you so much, and namaskar.
Namaskar, sir. Professor Tripathi, I am honored to interact with you. You have done marvelous work in the field of air quality. This particular field of research, Professor Tripathi, is the most relevant for country like India. As we know, 6 out of the 10 most polluted cities in the world are in India. And your entire research is focused on how to basically make air quality better for the people. This interaction, Professor Tripathi, is related to one of your projects, that is IoT-based sensor for industrial emissions and air quality monitoring, which was recently displayed in first ever Research and Development Fair exhibition held in IIT Delhi on 14th and 15th of October 2022. So my entire this interaction will be focused on that particular project only, Professor Tripathi.
Absolutely. I'm very much delighted to be here, and you are doing remarkable work. And I saw that you have a huge subscriber base, which is drawn from the people who appear for GATE and appear for other higher education engineering examination. Right. So I'm very much looking forward to it.
Okay, that's wonderful. Professor Tripathi, before I come to the project and technical parts of this, I just want to brief all my viewers here that we will be interacting on some of the very latest domains of research work in which you are working. You are doing marvelous work in Make in India domain. I found, sir, your low cost sensors and laser scattering sensors made in India. Very, very useful for Indian markets. You are doing marvelous work in discoloration aspect of Taj Mahal. You are doing contributing in national air cleaning programs, and we will be talking in this interaction about all these focus areas. Now, my first interaction point is related to you, Professor Tripathi. I was going through your entire profile and I found something very curious in that. I found that you are a graduate of IIT BHU long back in 1992. After that, you pursued your master's from MNIT Allahabad. So I was curious. Normally, this trend is not observed. People go from NIT to IIT, but you have gone from IIT and then you pursued your higher education from NIT. I was curious to know about that, sir.
Well, I mean, yes, it is true that this is not the normal trend that people go to NIT for PhD, a master's or PhD, but there are people. In my case, it so happened that during my undergraduate studies, I was involved in extracurricular activities.
Okay.
And at the same time, after my undergraduate, I took a job. I took a job as an engineer in one of the very leading PSU. And combined, both of them probably did not allow me to, study so well. And we did not have people like you who were running this YouTube channel so that you get more information. We did not have any coaching or anything. So yeah, it was not by choice. It just so happened that I landed up there. But fortunately, I did it in environmental engineering, and which had almost become a favorite subject for me by then. Okay. And then after that, I just pursued more and more in environment and meteorology and air quality and climate. So yeah.
Wonderful. So yours is the example, sir, where students, many students, those who are looking for doing marvelous research work in their career later on. For those who think that higher education only from IITs can provide them these opportunities, they need to realize that they have the opportunities for these domains from wherever they do marvelous work.
Absolutely. I'll just add there that we have some of the most outstanding scientists this country produced and is still producing, were there before even inception of IITs. So,
yes, that's true.
So there were universities, there are research laboratories, and there are still. So place and the environment does provide some right conducive, impetus to your research work, but these are not the only, prerequisite to excel in research. Yeah.
Right, sir. Wonderfully said, Professor Tripathi. My next interaction point is again related to your academic background, Professor Tripathi, and I found you have done 2 postdoctorates, one from Bhabatomic Research Center, very precious our research organization in India, and second from Oxford University. So I want you to tell us, sir, what is the significance of postdoctorate fellowship? Because as of now, the awareness about postdoctorate fellowships and all is very less among the researchers in India. So I want you to tell us about what is the significance of this and why 2 in your case.
Well, when I was doing PhD, postdoctoral research experience was becoming more and more sought after, because see, what happens that generally during a doctoral research, you are supervised by an advisor who happens to be either a faculty member or a scientist, tenured scientist, right? So that is why you always have this position that you are a research scholar and you have a supervisor.
Right.
So that you are not totally doing an independent research. Although a PhD student or a scholar is expected to gain independence in the latter part of their thesis, but still they are not really, they don't come out as a totally independent researcher. Okay.
Right.
It is the postdoctoral research that imparts them that independence. Right. And it is quite important that as a researcher, if you become independent, then you are able to create your own ideas, write research proposals about them, bring funding, execute them, then start, training your own students. So that is where a postdoctoral research experience is important. Now, as far as 2, in sciences these days, on an average, 3 to 6 years of postdoctoral research experience have become quite common. So 2 or even 3 sometimes, because generally a postdoctoral fellowship lasts from 1.5 to 2.5 years. So if you have to do 5 years, certainly you will have to do 2. In my case, I came because that time there was a very, you can say one of the most leading aerosol scientists was there in Bhabha Atomic Research Center. He became aware of my work, and I was very much interested in kind of carrying out the work he was doing, because my PhD was totally focused on aerosols. Okay, and that what drew me to Bhabha Atomic Research Center. And while I was doing, and I was actually offered a tenured scientist position at Bhabha Atomic Research Center, but that time another interesting problem came up, which was jointly conceptualized and executed by Oxford and Cambridge University. It was a joint project.
Okay.
And the project was so exciting that it just compelled me to then go to Oxford that time. Yeah.
Okay. So, Professor Tripathi, what I could understand from your answer, like postdoctoral fellowship offers you opportunity to work with some of the pioneer in particular field, as you said about Bhabha Atomic Research Center, and it also provides you opportunity to work on some project which you find very interesting, and maybe it is helpful to you in your later academic years. I want to ask you, Professor Tripathi, can somebody go for postdoctorate fellowship once he joins as faculty member also, or it should be done only before he joins the position of faculty in some institute?
So generally, IITs, to have a regular faculty appointment, it is expected that the person have PhD and some postdoctoral experience. Actually, it is mentioned as 3 years.
Okay.
Exceptions can be made, but those are not common.
Right.
But sometime, let's say a fresh PhD student join an IIT, I'm talking about first in the context of IITs,
Right.
then one could definitely, institute can permit, that depends on case-to-case basis, one can get leave to pursue a short or little long postdoctoral fellowship. This is quite common, by the way, in the universities, where universities still can hire faculty members, or laboratories, national laboratories, where sometimes people even join without having PhD. Sometime nowadays, actually, PhD has almost become the eligibility criterion for science and engineering anywhere. So when you don't have postdoctoral fellowship, definitely you can go either as a postdoctoral fellow or just any other fellowship which gives you opportunity to do some independent research in a laboratory.
Wonderful. So this is the main point, is like you should work independently on some project which makes you capable to handle such projects once you become the faculty member. Now I come to Professor Tripathi, to your main projects which was recently displayed in first ever R&D fair in IIT Delhi. That is IoT based sensor for industrial emissions and air quality monitoring. My next couple of questions are related to this project only, sir. I want you to elaborate the term IoT to all of us here. What do we understand by this IoT?
Yeah, Internet of Things, that is in abbreviated ways called IoT, is a way basically where you connect the physical and cyber world. Okay, right. So basically, as you see, that you have a physical world which is a real world, right? Like, and now we are connected through cyber world, right? So, but if you were next to me, then we will be talking in person. So that's a physical, and this is now cyber world. So you see, the computers are already connected using the cyberspace. That is, we know internet, or sometimes they are connected with intranet. So you can pass on information, you can access information which is somewhere, collected elsewhere, but is actually posted on the using the World Wide Web technology. Right. So the computers were already connected. Right. Then this idea came that can we connect these physical systems, right, using some kind of a network technology, so that one can optimize the performance of these systems. Right. So as an example, just imagine that you have a building, and in a building you like to cool it because air conditioning. So it's a large building, there are different rooms are occupied by different people. So different kind of activities are happening. The rooms have different settings. Some are on the top of the floor, is receiving more sunlight. Some are on the, basically facing the sun, which will probably get heated quickly. So the cooling requirement is different. Now, one way where you do not basically make use of these IoT connected and therefore optimized cooling is a thing that you have a centralized cooling or air conditioning system.
Right, sir.
And you simply cool all rooms in an equal manner.
Right, sir.
So regardless of the cooling requirement, so that's why you might be feeling that sometime you go in some room in buildings which do not use these IoT based air conditioning system, you suddenly feel very cold. This is very common that you will feel, you'll sure. In fact, we face very often these things.
Right.
And sometimes you are sitting in a room, maybe in a corner where you do not have sufficient cooling, and you just feel that maybe air conditioning is not working. It's not that. Air conditioning might be working, but it has no information that how much actual localized cooling is required at that place.
Right.
So how IoT helps with this problem? It makes use of measurement of temperature. You can put sensors,
right, sir.
These temperature measuring devices, simple devices in different part of this building,
Right, sir.
different rooms, different places, which will record the temperature, and this will transmit this information to the central air conditioning system or the air conditioning which is in that room. Okay. Now that you have a real-time interface,
right, sir,
between the requirement in a room of cooling, the cooling requirement in a room, and accordingly how much the air conditioning should work, so that you can achieve the optimal cooling in the room, so that it is habitable, that people live, and then there is no excess use of power. You save energy. So this is one example, I think, where IoT-based systems can optimize the performance of the entire thing. Now you can imagine now large industries where there are more than 100,000 machines are working all the time. Think about anything where somebody is making different component of a large, let's say, automobile or any such thing. Now, there are two ways to do things, that each machine do not speak to each other. Okay, then of course they may all be working in their own way, and there wouldn't be any synchronized performance. Now, if they are all connected through IoT, then they all will be actually speaking to each other, and therefore they can enhance the performance many folds. So that is the way. Then there are many such applications, and of course in environment also this is increasingly getting used to understand better that what is happening to the fate of environment, fate of the pollutant in the environment, and how we can deal.
Professor Tripathi, very beautifully you have explained, sir, the example of IoT through air conditioning in a building. And what I understood is, like, if we use it on large scale, there is going to be huge conservation of the precious resources, and it is going to optimize the entire resource utilities of the industries. I also understood, Professor Tripathi, that these technologies like IoT, these technologies find application in each field of specialization and in each walk of life. And we can use these technologies for making the lives better. That is what you have done, sir. And now my next interaction point is related to that only, your use of IoTs. In fact, you call it narrowband Internet of Things. I've heard this term first time, Professor Tripathi. In your devices, data is transmitted through novel use of power optimized narrowband Internet of Things. Now this technology and use of these technologies with precise GIS location is something which you have utilized, sir. So I want you to tell us, sir, what do we understand by this power optimized narrowband Internet of Things technology which you have utilized?
Right. So you see that currently, in order to connect with people, we use the most common way today. We use either cell phone or internet.
Right.
Now, cell phone is more common because everyone has access to that.
Right.
Until very recently, we were using 4G, and now we are transforming slowly to 5G. Right. Okay, basically just to have enhanced experience of that entire communication, gamut of communication. Right. Now, you see, when we communicate to anybody, a person when is talking to other person, so when this this whatever signals that first goes to the nearby tower. You see that those telecommunication towers, which are generally next to you or in your neighborhood, it goes there, and then it relays the signal from there to your person who you want to communicate to. Okay.
Right.
So this process, basically the transmission process, consumes enormous amount of power, and that is why you see all these towers basically have alternative arrangement to for power, so that in case of, let's say, regular power supply is disrupted, they have their own genset, etc. And so this is a highly energy consuming process. Now, between 4G and 5G, then telecommunication technologies came out this idea of narrow bandwidth, Internet of Things, which is basically, it can allow these towers to connect or transmit to many more devices for the same amount of power. Okay, that is why it's called that it's a very power saving technology. So 4G is a technology which basically uses some frequency. As you know, they all use basically some frequency to transmit the data, right? 4G. Now 5G has something. Now this particular narrow bandwidth uses a channel, and the kind of channel it has found out, the frequency it uses minimize the power consumption, and therefore leads to good amount of energy saving. And that is what we tried also, because these devices actually were developed back in 2019 and were first deployed in Delhi, because this work was the first time we were using sensors before for monitoring air quality, but having narrow bandwidth Internet of Things in the sensor were tried first time in 2019, and it was supported by a telecommunication company, international telecommunication company, right? Which had good interest in understanding the data transmission, and thereby, in doing so, the saving of the power. And that is why they suggested us to use this NB IoT. So whatever sensors we implemented it, they must have also, because they were, this telecommunication technology with the telecommunication service provider in India, they both combined basically were our partners. So they looked into the data, and certainly they must have found that it leads to power saving. So this is first of the field implementable kind of work with the narrow bandwidth, and particularly in the case of environmental sensing, which was done in the country.
Wonderful. Professor Tripathi, you are doing marvelous work in field of sensors, and that is also leading to Make in India initiative of the government also, I believe, because indigenous kind of sensor development, as you just mentioned, sir, first of its own kinds. So I also went through, and I could see the application of laser scattering sensors in your work. My next question, the interaction point is related to that only. So your devices are built using a laser scattering sensor, and you are measuring PM 2.5, that is particulate matter 2.5, which is a very, very important index for measuring the air quality index, Professor Tripathi. So we want you to explain and tell us what is laser scattering sensor.
Well, see, particulate matter are basically these objects. Basically, they are colloidal systems. We call colloidal because they have different phase than air. They are dispersed, or they are basically hanging in the air, and they are colloidal. They can be crystalline, or they can be, droplet, if they have lots of water. But generally, when we talk about particulate matter, they have less water. They are mostly crystalline. Now, idea is that how do you come out with some measurable way, quantifiable way, so that you understand how much they are there in the air, what you breathe. So one way is basically you try to launch a particular light. Okay, and you all know that if you ever go outside and if you have some dust present, and if you stand, and you must be seeing those dust particles in the basically in the pathway of the sun rays which comes to near you. You must have seen those, right? That even very tiny particle. Why do you see them? Because they interact with the light, they absorb and scatter.
Yes.
And that is why that scattered light comes to your eyes and you see them. Your eyes are detector. And in this case, the light is not from laser, it's from sun.
Yes.
So likewise, if you now don't think about sun, you think you have a laser. Okay. So you are basically kind of launching or sending a light pulse from a laser. Just like a laser, you can, and you can make use of any wavelength which works best for detecting or interacting with these particles. Because what you want maximum signals to come to your detector. So in that case, now in this engineered system, you don't have eyes as a detector, you put a detector. So you have a laser and you have particles. Particles in the air are always coming in the path of laser. They will scatter light and the scattered light will be detected by the detector. Now that signal is actually kind of calibrated with the amount of particulate matter. So if that signal you can quantify and you can measure, then using the calibration factor, you can get the total amount of particulate matter which is present in that particular volume. And that is what you do.
Wonderful. Professor Tripathi, one question just popped up my mind. It is not a part of this my script, but just the way you explained it popped up my mind. Like, why not, Professor Tripathi? Because sunlight is a white light, but laser is a highly coherent beam of light. So why not white light? We replace sunlight with a white light instead of laser light to make such sensors.
No, you can't, because see, you need, particulate matter 2.5 is basically PM, which has size less than 2.5 micron. So, and that also has a distribution. All particles are not of 2.5. This has a very continuous distribution. That means particles are having sizes from few nanometer, from few nanometer to 2.5 microns. So it is basically 3 decades of variation. Right? Now you kind of choose, looking at, if you draw a distribution, you will find that there will be a mode to it, where largest number of particles are. So maybe it could be 0.6 micron or 0.5 micron. You will find that largest number actually will lie there. So you know that this scattering phenomena gives you largest signal when the size of the particle and the wavelength of the light you use have a ratio as a, and that comes from the theoretical understanding of it, which is called me theory. So me theory gives this idea very clearly, not idea actually, it's a very clear theory with a exact expression for scattering coefficient. So the choice of the wavelength of light comes from the knowledge about the size of the particle, and that's how you choose it.
Right. Wonderful. Professor Tripathi, you have already mentioned about the PM 2.5, but my next interaction point was related to that only. Actually, PM is one of the very, very important index or parameter, I must say, that is used by World Air Quality Report also. When they make their IQ air quality report, they are also using it. So what do we mean by 2.5, that PM 2.5, the word which we are using, Professor Tripathi? So what do we mean by 2.5? Is this some kind of size in micrometer or something?
It is size actually in micrometer. See, there can be PM1, there can be PM10, and you know, for health purposes, that because this is most injurious to health, because air quality standards are designed based on the epidemiological data, which has been collected globally and mostly the developed world, that a particle of particular size, what kind of adverse impact it has on human population. And that what basically gives us this idea that PM 2.5, as I said, is the most injurious. Now, why 2.5 means that all concentration, mass concentration of all particles having aerodynamic diameter less than 2.5 microns. Now, why do we use aerodynamic diameter in a very short way? Because these particles do not actually have a spherical shape. If they have a spherical shape, then you basically use a spherical diameter. But they have complex shape. So what you do, that you take a sphere and this complex shape particle, and if a sphere of 2.5 micron diameter, and your particle of, your particle have equal terminal velocity. Equal terminal velocity, when they start, they tend to fall with the same velocity, then you call this non-spherical particle has a diameter of 2.5, aerodynamic diameter of 2.5 micron. So that is how you define it, but it is actually to get an idea about the size.
Wonderful, sir. Professor Tripathi, my next question is related to the connection which you see between air quality, public health, and climate change impacts.
See, air quality is having a whole range of adverse health impacts. So there are now studies and which are backed up by data, and this has been published in places like journals like Lancet, which is a very respected journal, and Nature, that there are about 6 million plus premature deaths which occur globally because of that bad air quality or people, exposed to air pollution. And this number goes about 1.8 million, that is 18 lakh in India per year. Now, this is about the premature death, but there can be other short and long-term effects which can reduce the overall quality of life, right? Not necessarily resulting in death, but there can be other factors. Now, problem is that these very small particles actually can bypass the filtering mechanism which are built in our respiratory system. See, these large particles can be trapped in the upper respiratory tract. As you inhale through your nostrils, and that as it enters, many things are filtered, which are bigger than 3-4 micron. But this 2.5 micron can somewhat make its way into your lungs. And if they enter into the lung, then possibility is that from there they can go into your bloodstream, and through the blood, then it can start getting into your different organs. And that is where earlier people thought that mostly it can affect you adversely through some respiratory problem. But now that many other things are emerging, and including COPD, cardiovascular, and then cancerous, many particles which are having different kind of metals which are known carcinogens, cancer causing metals or elements, they are also leading to basically finding of cancers in the people who are inhaling that. And then just now there is a study which came out which tells us that even now one particular kind of particulate matter, which is called this soot particles, right, which come from mostly automobile or burning of fossil, is also called black carbon, is able to enter into the cells of the embryo which is developing in mother's womb. So this study just came out 3 weeks back in UK in a very, very prominent journal. So this is what currently we are seeing, that air quality is emerging as one of the most significant environmental health challenge globally.
Right, sir.
Now, climate and air pollution connection is more complex. Okay, but definitely greenhouse gas we don't consider as a pollutant as such. Of course, it also comes out from those burning of fossil fuel, but that have a different kind of consequence to the planetary let's say system and overall climate. But some important pollutants like black carbon, ozone are known to have short-term warming effect. Just like the greenhouse gas has a warming that happens over a time range of few decades. Likewise, the soot particles and ozone can cause warming over a time scale of few years. So that is why they are called short-lived climate pollutant. So if you can curb them in short time scale, you can have climate benefits. And likewise, then there are other such pollutants which have other kind of effects on climate change. So these are more complex, topics.
Yeah. So certainly, Professor Tripathi, there are concerns, and there are serious concern for the public health.
Yes.
I was observing, Professor Tripathi, one trend. I was going through this World Air Quality Report, and I observed something very peculiar there. I found that out of top 10 most polluted nations in the world, cities in the world, 9 are in India and Pakistan itself. One is in China. That is what I saw. I think 2021 report, and that too in northern part of India, Professor Tripathi. So I was curious whether is there any kind of reason, Professor Tripathi, because we have other developing nations also in the world where inefficient utilization of the resources goes on. Least developed countries are also there, but why only India and Pakistan out of top 10 cities? Why these two nations, that to northern part of India?
Well, I would not give too much importance of this kind of, ranking or listing the cities in terms of how polluted they are. Because see, many countries may not still have that kind of monitoring happening what we have. So if you don't have monitoring,
Yes.
for example, many cities in India still we don't have monitoring. So
Yes.
you don't know where they stand.
Very relevant.
So, but on the whole, India has already about 700 to 800 stations where monitoring is going on, whether manual or in real time,
Right.
and the data comes to central server to CPCB. Right. So you have more information, and now many other countries which are also developing, as you rightly said, and passing through similar processes, but because of lack of monitoring we don't know, and therefore it's difficult to comment. But nevertheless, I believe that the pollution is a serious concern. Air pollution is a very serious concern in India. And that is why we have such a comprehensive program which was launched in India, National Clean Air Program.
Yes, yes.
And under that, things are happening, and hopefully more things will happen in future.
Understood, Professor Tripathi. I got the answer for my query, because monitoring should be in place, and that is where your research work comes into place, sir. My next interaction point to you is related to cloud microphysics, Professor Tripathi. So, what has been impact of your work on cloud condensation nuclei, CCN, which we call, and cloud microphysics?
So, cloud, aerosol and cloud related, or the connection between them, our group were one of the first to explore that in the country. So long back, we had conducted an airborne experiment, which was a part of Continental Tropical Convergence Zone, which was supported by Department of Science and Technology. Cloud condensation nuclei are basically a subset, a small part of these particulate matter, which generally we call then aerosols. Particulate matter you call in air quality lingua, and in climate studies you call it aerosols. Right. So a subset of aerosol on which droplet can form is called cloud condensation nuclei. Not every aerosol can convert into droplet. There are certain characteristics, mostly its size and its chemical composition, which determine whether it can form as a cloud condensation nuclei or not. Okay. Now, with the increasing amount of aerosols in the atmosphere, there are studies that show that these aerosols can have a variety of effects on cloud properties. And which basically, when we say cloud microphysics, that means on the cloud droplet properties, its distribution, ice particle distribution, and both of them have important implications to the overall rain formation and then what rain you receive. Okay, so this is what we, as I said, we explored using a whole set of instrumentation in aircraft. Okay. And we flew about 100 plus hours in 2008 and 2009. These were the first airborne measurements of cloud condensation nuclei to understand the relationship between aerosol and cloud microphysics, which led to actually conceptualization of a major government program, CAIPAX, Cloud Aerosol interaction and rainfall enhancement. That was basically led by Ministry of Earth Sciences starting in 2010, and 9 when our program was concluding. And then as a follow-up, some of work we did looking at the data and as well by setting some careful modeling experiment, we had a very interesting paper that came out actually in Nature Communication that showed that these CCN or aerosols can not only contribute to or modify cloud microphysics over Indian region, but it can also connect to the cloud macrophysics, that is the shape and size of cloud. So that's called macro, not micro, macrophysics, and which can have important implications to the rainfall and the overall climate over Indian region. So that is some of the things we did.
Wonderfully explained, sir. My next interaction point, Professor Tripathi, is my favorite interaction point, and that is related to Taj Mahal. Taj Mahal is one of the wonders in the world and pride for India. Whenever somebody comes, visits India, he goes to Taj Mahal. So Taj Mahal every year attracts more than 6 million people, and people go there, visit it. Your work on the discoloration of Taj Mahal is well known, and that is very relevant work, Professor Tripathi. The finding of your study led to stricter enforcement and legislations changes to prevent the monument from getting discolored. What are the findings from your side, sir? We want you to please explain us what were the findings which brought so positive change in protection of this particular monument.
See, Taj Mahal is known to be, getting impacted by the pollution, and then regular efforts were made to clean it. Right. So if you have happened to be in the Taj Mahal premises, you have seen that every 3 to 5 years, they create a huge set of scaffoldings and they tried a particular kind of mud, right, to clean it. And which is a big effort, and not necessarily it can give the original texture and color of those marbles which are used to make this monumental heritage building, right? Yes. So this prompted us to understand what are the pollutants which are causing the discoloration of Taj Mahal marble, marble surfaces. So earlier speculations were that these are because of the gaseous pollutants which deposit and then cause the discoloration. So doing a 1-year-long ambient sampling and then collecting the particles also on surrogate marble surfaces which we placed in Taj Mahal premises, and then doing some interesting modeling and then connecting with the way human eyes visualize objects, that all these 3 or 4 components led us to get that these discoloration is mostly caused by deposition of particulate matter. And 50% of that is because of those which comes from anthropogenic activities like carbonaceous particles, and 50% is because of dust. Some part of that also can be anthropogenic in nature, but good part that could be of natural origin. Yes. And then as a follow-up study, we found that 2 major sources which are located in the vicinity of Taj Mahal in the Agra city, which are basically the municipal waste burning and the dung cake which you get from cattle. These 2 contribute to the good part of these carbonaceous aerosol which were found to be deposited and contributing to the discoloration of Taj Mahal. And that led to basically interventions by Parliamentary Standing Committee at that time on Science and Environment, and backed up by the local administration of Agra, which restricted flying of vehicle in the immediate vicinity of Taj Mahal. They also, I think, kind of mitigated some of other point sources which were there in the next to Taj.
So that was indeed a great contribution by you, Professor Tripathi, through your research in protection of this national heritage. That was wonderful, sir. Your work, your research work is also contributing a lot into making a very good policies and programs by government. My next point of interaction is related to India's ambitious National Clean Air Program. So, what has been the contribution of your research work, sir, in this? And please tell us about this program.
So this program actually is the first comprehensive program to deal with air pollution at the national scale. See, earlier efforts were more targeted to a particular region or a city. So first time in 2019, this program was conceptualized, and altogether 133 non-attainment cities are brought into the ambit of this program.
Okay.
And the program rests on three pillars. Mainly, idea is to generate more science about and understanding about air pollution, create more capacity amongst everyone who are responsible to contribute to the solution or solving the problem, be it pollution control board or the institutions who are working in that direction. And third is also based on these two, then also try to mitigate sources in 5 major economic sectors, which are identified to contribute most to air pollution.
Thanks.
Now, we have been working a couple of things. For example, one thing we tried in Delhi NCR, followed by Lucknow and Pune, is a real-time source apportionment technology.
Okay.
Where rather than, using this conventional way of source finding technology, where you have to wait for 2 years before you get the result. So it's slow and it's uneconomical, and it doesn't give very granular information about sources, the conventional way, which were used before.
Okay.
We build on some of our expertise of which we acquired over a decade about in the mass spectrometry. So many of my students have worked on that. So using that, which gives you online real-time information about particulate matter.
Okay.
And then you can run a model to get near real-time information about sources. So this technology was tried in Delhi NCR, which was supported by Central Pollution Control Board, followed by in Lucknow and then Pune. And now we are, in fact, since it is very fast and it gives very precise information about subtle sources. Just to give an example, for example, it can separate out the contribution of the tailpipe, that what comes from vehicle, from the tailpipe, from the exhaust, and what is contributed by brake and tire wear. So these kind of distinctions can be made, which is not possible with the conventional. But it is also resource intensive.
Okay.
So to overcome that, now we are making use of sensors, which were part of that, what we participated in the Maiden Ministry of Education event, IIT's Fair. That making use of sensors, we try to train the sensors with such kind of infrastructure and start getting information about sources. We call it dynamic hyper source apportionment. It is dynamic because it can give you instant information, and it is hyper because you can scale it to as many places where you have sensor-based data coming. Okay, so this is one contribution. Other, we also suggested and then formulated a network of institutions, because looking at the scale of this program, currently we have 133 cities, but in future more and more cities and towns and the rural areas will be brought into the overall purview of this program. So idea was that if we can connect most of the technical institutions, IITs, NITs, national laboratories, and universities where active research program in air quality is going on, active research and teaching program, then, and they can be connected with these cities. Okay. Then they could contribute to the implementation of these programs on the ground by giving technical and scientific solutions and inputs in real time. So this is called Knowledge Network for National Clean Air Program. So these are some of the things. Of course, there are many other things which are happening at the state level, at the city level. As we speak, we are trying to, put sensors network in many cities and states. We are working with the state boards, state governments. But these are some of the things I think I will.
Very well explained, Professor Tripathi. And my next point was related to this only, which you have already thrown light on and you have explained, sir. That was real-time source apportionment, RTSA it is called. So you have already explained this particular thing in your earlier interaction point. My next interaction point is related to low-cost sensors, which are made in India, though we have already talked about that earlier. So when we say made in India, sir, are we trying to make indigenous, production of these kind of sensors in India? What these are and what is the status as of now?
Yeah. So you see that currently that the monitors government uses are called continuous air quality monitoring system, which has 2 monitors for measuring particulate matter and generally 4 to 5 analyzers to measure gaseous pollutants.
Right.
And altogether, it costs you somewhere from 1.1 to 1.4 crore
right.
per monitor, including the capital as well as the perpetual maintenance cost for 4 years, right?
Right.
So compared to that, these units which we are developing with our associate startups can cost you 3 lakhs,
okay,
which has the capability to measure particulate matter as well as gases, and we have developed a variety of calibration model. Now these units have following things, which cost you 2.5 to 3.5 lakhs, has measuring, the sensors which measure these pollutants.
Okay.
It has a battery. It has to have a storage system for storing the data. It has to have the transmission protocol. Also, if require a power backup in terms of solar. So there are a variety of things which are within this unit. Now, as of now, particulate matter sensing, that particular sensor is not fabricated in the country, but we are now going to do that. We have been given a center of excellence by the Office of Principal Scientific Advisor. It is approved by their office and it is supported by private entities. Totally, it is basically very much, you can say it is in PPP mode. Okay. Public-private partnership. Yes. So with this support, our colleague who are expert in fabrication, they are expert in fabrication of nano devices. We are starting this work in IIT Kanpur from the help of physics department colleague and electrical engineering colleague. The fabrication of this sensor, which actually costs only 100 of these 3 lakhs because they are very small. But they, as of now, they are only manufactured by few countries. Okay, but now because there is a lot of push under semiconductor program of government, and before even that, in the center we have envisaged that we will fabricate that so that the entire unit becomes an indigenous effort. Okay.
That's wonderful, sir. And I'm sure this is going to contribute in Make in India initiative of the government to make the technologies more and more indigenous. Professor Tripathi, I want you to tell us something about SATVAM, which acronym is for Streaming Analytics over Temporal Variables for Air Quality Monitoring. So what is this, sir?
So when I started working on sensors, and that time there was a call under Water Air Quality Management Program, conceptualized by IUSSTF, which is a body set up by Government of India to promote bilateral research between India and US. And that's why it's called India-US Science and Technology Forum. And under WAQM program, they called for basically projects that can advance the science and technology of sensors. And under that, we were funded a project which was called SATVAM. And that project actually has 4 major components. One was to better understand sensor, that how how precise and accurate these sensors are. We had very little idea at that time when this project started in late 2017.
Right.
Second was improving the transmission, that is the network part of it. So we had some people from Indian Institute of Science. Then we had collaborator from IIT Bombay who developed new electronic boards, the boards where the chips are, where the sensors are placed, and where all the data is transmitted and stored. So they actually helped us creating new board. And we also wanted to make use of this additional power, backup power, because many times these sensors could be placed in remote areas where a regular power supply could be scarce. Okay. So that also we have colleague from, you can say, solar in mechanical engineering at IIT Kanpur. And finally, we wanted to do real-time analytics, and currently we are doing that a lot. Now we have these networks running in many cities as an initiative of IIT Kanpur with under support of the center I talked about, which we call as Atman Center. They're also an acronym. And that time idea is that many analytics we do on these devices, or the devices are connected through routers, and then it is put on display. Just to give an idea that if you have a network running in a city, you have 50 sensors running. Now think about that, a city where there are 2 government monitors and you have 50 sensors. So just imagine that the overall volume of data you are going to get. Now with 50 locations data and coming every minute or 5 minutes, you can do a lot of visualization of the data. And then you can put it on the web, you can put it on the cell phone, you can do it through apps where people can just sitting on their cell phone or their computer or anywhere, they can look at it, that what is happening in the vicinity. Right. Whether they can go for a walk in the morning or they can take their kids for to the playground. That was the basically idea, that time and space, that what comes in Satyam. Using that data, space, time variable, if we do real-time analytics.
Wonderful.
So that was basically done in that project.
Yeah. Professor Tripathi, after this marathon interaction session, we are coming almost to an end of this wonderful session I had with you. My last interaction point is the most interesting one also, sir. So your work, that is providing the clean air and monitoring of the air and then leading it to its clean air provisions for the people. So this is one of the very important point of sustainable development goals, that 17 goals which we want, and India is also committed to fulfill it by 2030. So I want you to throw some light, sir, on new technologies which we are conceiving nowadays to do away with the fossil fuel based technologies. So we talk about e-vehicles today, we talk about green hydrogen today. So I want you to tell us what impact you foresee of these technologies on the air quality on planet Earth.
No, both are going to have very positive effect in tackling or combating the climate change and also mitigating the dangers of air quality related problems. Because see, both are replacing the fossil. Right. You go for e-vehicle, so you are replacing, the diesel, petrol, and even other kind of CNG, which also causes some amount of, pollutant gases to come out, and even some fine particulate matter. Right. And when you are using green hydrogen, then again, using green hydrogen, you can actually generate any kind of, energy for any purpose. Right. So again, you are basically totally replacing that fossil fuel. So whenever you are replacing fossil fuel, you are basically replacing 2 of the products which come out by combustion of fossil fuel. Right. Most importantly, carbon dioxide. Then maybe second level is the methane. Both are important greenhouse gases. And the third, because any time your combustion cannot be 100% efficient, so particulate matter will come out. So going for these 2 definitely is the way forward. Green hydrogen is very futuristic. And since country is on the path of large infrastructural changes, then there is a huge potential to develop the infrastructure, because green hydrogen handling, is little complex, because being very inflammable, right, you have to be very careful about it. Right. But the countries who already have developed, right, the developed countries already have taken path for certain kind of energy option.
Right.
So they might have to totally undo or redo it. But we are still doing solar, and we have still a lot to do. So we can develop, and then more importantly, we also have large coastline. Right. So the green hydrogen, generally you do it by doing the desalination of the water. So you have abundant water. So if you do, I think it can also help us to get more. When you desalinate it, some part can be used for hydrogen and some can be for drinking water. So definitely, I think we should go ahead with that, and India could be a very leading nation in the green hydrogen production.
Yeah, that's wonderful, Professor Tripathi. Sir, we have come to an end of this wonderful session, but I want some message from your side. Professor Tripathi, majority of the viewers on my channel are those students who are looking forward to pursue career in research and higher education and make some change through technology. I want, sir, your advice to all such students that what are the field of research areas in your domain, I mean, where they can think of pursuing their career in the research in your areas of specialization. And if some student wants to work under guidance of professor like you, what do you see in them and how they can groom themselves to work under the mentorship of person like you?
See, now compared to our times, there are a lot more opportunities which have been made available in the country to either do research or do technology development. Right. Most of the IITs currently are already have opened research parks, well, in the innovation hubs, innovation centers. So while carrying out research, if you have interest or if you have some entrepreneurship, you can, and some knack for developing technology, you can pursue all three. Which earlier was not possible. Now, while the country is developing, I think protecting environment and for sustainable development, as we call, is going to be an important challenge. Yes. And therefore, I think there is ample opportunity to explore the major environmental problems in the country. Excellent. So, even if, let's say, you are going abroad and you are learning new things, definitely I think one could think of utilizing those knowledge to contribute to, the country's kind of protection of the environment in our country. I think that's going to be one of the major challenges in the coming days. So that's what I would say, that please look into that.
Wonderful, Professor Tripathi, and I'm sure, sir, during this 1 hour of session, whatever things have come from your side in the form of knowledge and information, that is going to be very, very relevant for, sir, the students and those who are looking forward to pursue career in this particular area, in this domain. And at the end, I will again say, sir, the research area in which you are working, that is very, very relevant for countries like India, and that is directly related to the quality of life, which is the fundamental right given to the citizen of India by our constitution, right to life. You are working, your technology is penetrating into that domain. It's a marvelous work, sir. And I'll again thank you for giving your very, very precious time to me this morning. I really thank you for that, sir. Namaskar, sir.
Thank you, Vijayanji. Thank you very much. And it was a pleasure talking to you, and my all the best wishes for your channel and to all your subscribers.
Thanks a lot, sir.